Hello friends, welcome back my YouTube channel MS Maths. In this video, I will discuss the equation of motion under impulsive force. So first of all, we should have an idea about that what is the impulsive forces. So before going to the impulsive forces, we should know about that what is the impulsive function or what is the meaning of the impulse. Impulse is basically for a second or for a particular small time, it should be a large quantity. It means if I define the impulsive function, it means it is a function of f of t in t is a time, then it is infinite value for some t plus delta t. It means if I will define like this is my function and it is my t values, it is my t and it is my f of t, then for t to t plus delta, it means for this range it should be it will be infinite. It is infinite, or for all other range it is 0. Okay, this is the impulse function, and where it is t and it is t plus delta t, and this difference is basically the delta t. So basically for this particular interval, the value of function is infinite, or it means we can't calculate, or it is basically for that small time period it is very large. And for all other, like other than this interval, the value of the any function or any like force, even if we discuss with the respect of force, then on the other interval the force will be 0. Okay, so this is called the impulse function, or on the behalf of the force it is called the impulsive force. Okay, so let us consider that fluid motion is subjective to the external impulsive force. It means we are applying the force that is the external impulsive force. An impulsive force is a force that acts for a very short interval of time. This is basically delta t is very short. Basically this delta t is very short time period. Okay, now we have, let S be the surface enclosing inviscous, or basically it means the non-viscosible fluid and incompressible fluid of volume V. If I will define some surface in such a way that if it is my surface, and basically this is the my unit volume is basically the dV unit or delta V unit volume. This is my whole volume is capital V, and this is the delta V, and this is at point P. Then there are two different velocities, basically q1 vector and I say some other velocity is q2 vector. Okay, and I have one small surface is basically the ds, whereas the pressure is P and the normal is n cap here. Okay, then the force, or the basically the external force F vector be an external force per unit mass, and let q1 and q2 be the velocities of the fluid at point P on delta V within the surface, just before the impulsive force and just after the impulsive force respectively. It means q1 is the velocity before the impulsive force and q2 is the velocity after the impulsive force. Okay, let P be the pressure on the element ds and n cap be the unit outward normal vector on the ds. Let rho be the density of the fluid applying Newton's impulsive law of the motion on the S. It is basically the Newton's law, like that is basically F is equals to ma, and we know that what is the F is equals to ma. M is basically the mass of the fluid, and we can write in such a way that it is nothing but change in velocity, that is basically the dq by dt, or else we can write in such a way that in the form of momentum it is basically the m d of m q vector upon dt, whereas m into v is nothing but the momentum, so we can write it as d capital M by dt, where capital M is small m into q vector, and it is called momentum. Okay, now where force is basically the change in linear momentum. Okay, now we have F dt is equals to d capital M. The total force, what is the total force on the surface is basically the, we have the total force on the surface is due to closed volume V rho F dV F vector plus negative direction minus of on the surface as is basically the n cap ds. Okay, it is basically the change in momentum. Okay, where force is basically the change in momentum. And what is it represent? It represents the force on the mass, and it represents the force on the surface. Okay, now we have the total force in such a way that F is equals to ma. Then we can write, this is my F, that is basically the rho F vector dV minus S P n cap ds is equals to m into change in velocity is the V is m, linear momentum change is basically m into q2 vector minus m into q1 vector, but we need in terms of rho and V. We have not V here, it means volume here, so we can write in such a way that by using the Gauss divergence theorem, by using the Gauss divergence theorem, GD theorem, says that the change in the change of the surface integral to the change of the surface integral to the volume integral, it means SP n cap ds is nothing but del cross p vector dv. Means we can write in such a way rho f vector dv minus this will be the volume integration, means it will again it will be a volume integration in such a way that it will be the gradient p vector dv is equals to rho v, and we can write this quantity as rho into q2 vector minus q1 vector dv in the form of rho and v, because m is basically the like what is the density? Density is basically the volume upon like volume, like density. If I have density, then it is mass upon volume, and I can write the mass in terms of rho and v. Okay, now I can write it because of all the integrals are basically the volume integral, so we can write in such a way that p f vector, sorry not p, rho f vector minus del delta into p vector, and we can write it as minus of q2 vector q1 vector dv is equals to 0. Now if integral will not be equals to 0, if this quantity will equals to 0, then this integral will be 0. It means rho f vector minus delta p vector minus rho q2 vector q1 vector is equals to 0, then it is true if and only if. Now we have q2 minus q1 vector is nothing but f minus 1 upon rho delta p in vector form. Also write, like we can write this is basically the equation in vector form. We can write it as an we will write it as an wait okay, so this is the vector form. Also we write it in Cartesian form. So we can write in such a way that within the components here we have f vector is nothing but fx I cap plus fyj cap plus fzk cap. In Cartesian coordinate means like that x, y, z axis, whereas q1 is basically the ux I cap or sorry, we can write in such a way that it is basically the change in u direction, that is u1 I cap plus v1 j cap. It is basically the change of velocity in the y direction, and sorry, change of position, or basically velocity in y direction, velocity in z direction is w1 k cap, and q2 vector is basically the u2 I cap plus v2 j cap plus w2 k cap. Okay, then we can write it as u2 minus u1 is equals to f of x, right? Like you can write it is for x direction. q1 minus q2 means the component in the along the direction x, the velocity component along the direction x for u2 minus u1. Then f of x minus 1 upon rho. This particular del will be the this delta. What is this delta? This is the del by like dou by dou x I cap plus dou by dou y j cap plus dou by dou z k cap. So it is basically the dou p by dou x along the direction, along the x direction. Similarly, it will be the v2 minus v1, then fy minus 1 upon rho dou p by dou y along the y direction, and this will be w2 minus w1 is fz 1 upon rho dou p by dou z along the z direction. So this is basically the Cartesian form of this equation in the like in the effect of the impulsive force. And now we can generate the cases also when F, or basically the impulsive force is 0. It means the external impulsive force is 0, is basically the q2 minus q1 vector is 1 minus 1 upon rho delta p. It means it is basically the delta dot q2 vector minus delta dot q1 vector, taking the gradient both side, minus 1 upon rho p. So we can write it as, like, if it is a incompressible fluid is incompressible, then what will happen? This particular part will be 0. So 0 is equals to 1 upon rho delta p, or sorry for that, it is delta 2p. Okay, so it means we can write, this will not 0, so delta 2p will 0, or where we can write it as delta 2 is nothing but dou 2 by dou x square I cap plus dou 2 by dou y square j cap, dou 2 by dou z square k cap. So this is your delta 2. If it is 0 and irrotational, it means, now see, what is the meaning here? Incompressible fluid. Incompressible fluid means the divergence of q is equals to 0. Okay, and now we can take the case of the case number 2, where f vector is equals to 0 and fluid is irrotational. Irrotational means that curl of, or del cross q is equals to 0, means curl of this will be 0. It means I can write q2 minus q1, q2 minus q1 vector is, when f is 0, then it will be 1 upon rho delta p, taking the scalar function like in such a way that q1 vector is equals to minus delta phi 1 and q2 vector is basically minus delta phi 2. The potential functions are here, so that we can write in such a way delta phi 2 minus delta phi 1 is equals to minus 1 upon rho delta p. So it will be basically the because of that these both are minus, then it will be minus and it will be plus here, or we can take the minus here though, so then we can write it as minus delta phi 2 minus delta phi 1, then 1 upon rho delta p. So now we have we have seen that taking the, like on multiplying the dr both sides, so it will be delta phi 2 minus delta phi 1 into dr is equals to 1 upon rho delta p into dr vector here. So the like the scalar function, where this is a scalar function because it is a vector quantity, it is a vector quantity, then it is the dot product is basically the scalar function. If it is a scalar function, then I can write this is a dr. So this is the derivative of phi 2 minus phi 1 is basically the derivative of 1 upon rho dp. So that, or 1 upon rho dp, or we can write it as simply p. Okay, it is p. Then taking the integration both side, we can write in such a way that phi 2 minus phi 1 1 upon rho or some p plus constant c. This is basically the two cases of the equation when the impulsive force is absent and irrotational, and impulsive force is absent and fluid is incompressible. It means in one case the divergence is 0 and second case is the curl is 0. So this is all about the equation of the motion under the impulsive force or under the effect of the impulsive force. So thanks for watching my video. Keep watching MS Maths. For more videos, you can subscribe my channel. You can follow the playlist of the fluid dynamics, and you can also follow the playlist of the numerical analysis for the computational numerical analysis. So this is all about this particular course. So thank you. Bye bye.